good afternoon or good morning, wherever you are, and welcome to our webinar on Linux scripting for the uninitiated. I'm Billy Stewart, architect at Winelect, and today we're going to be talking about all the nuts and bolts of what goes into Linux scripting, and particularly using scripting for a lot of different purposes. So this is going to be part programming and part practical application for Linux scripting. But before we dive in, just a little bit of background about why we chose to do this and who Winelect is. We chose to do this because so much of what goes on the cloud nowadays is centered around Linux and Linux hosting. So whenever you're talking about virtual machines, Docker containers, whether you're talking about things like Cloud Shell or DevOps automation or any of these types of things, scripting, particularly Linux scripting, becomes very important to making all of that happen. And it's kind of the glue that makes all those things work. And where Winelect comes into the picture on that is Winelect is a Azure partner with Microsoft, and we are a gold partner in the cloud offerings for Microsoft, as well as several other things related to that, Azure DevOps being one of those, and data. And we have numerous people on our staff that specialize in Azure that do a lot of things with DevOps and with Azure architecture, and specifically around infrastructure as a service and how to get that up and running and how to automate deployments for that. And so we like to share knowledge at Winelect as well. So one thing that we do as well is do training, and this is an extension of our training offerings when we offer webinars online. And so one of our lines of business is we provide training on Azure and many other technologies. And today we're going to be looking at doing some training around the Linux scripting, particularly on Microsoft Azure. So let me get my deck going here. And so with that out of the way, I want to dive right into the content and start talking about what is a shell, and talk about what this thing is that we call a shell, and then talk about some of the verbiage or the defining some of the vocabulary that we use when we talk about shells and shell scripting and the many other things that go into making this possible. So what is a shell? First off, a shell is a program that takes commands from the keyboard or terminal and gives those to the operating system to perform. So strictly speaking, a shell is just a user application that gives you a experience that's more user-friendly than just doing straight-up stuff with the actual operating system. So it's actually something that sits on top of the operating system, but it does integration with the operating system that you're working with. So it itself is not the operating system. However, it is very integral to the experience that you will have with the operating system. Bash is the one that we're going to be working with today, is one of the many shells available for Linux, and it's by far the most popular. So if you spin up a VM in any major distro nowadays, 9 times out of 10, it's probably going to be running Bash under the hood. And Bash, as we know, is it's a shell environment, but there are other ones that available that people use, and a couple of other common ones are TC shell, Corn shell, C shell, and Z shell. And all of these different shells, you can install them on any particular version of Linux that you like. I mean, just because you default to Bash doesn't mean you can't use something like Corn shell, which used to be very popular, but most of them have a default shell. So if you're looking at most scripts, or you're looking at most commands that people are offering online, it's probably going to be using Bash for that. So for my purposes today, I'm going to be talking specifically about Bash. However, that doesn't mean that most of the stuff that I'm going to be talking about can't be translated into other shells that we're going to be using, that you can use with Linux. So the next thing that we want to talk about is what is a terminal. Now, a terminal and a shell are not the same thing. Oftentimes they're conflated. A terminal is not a shell, and a shell is not a terminal. A terminal is simply an application that you run locally to connect to a shell environment on a local system or remotely. So the terminal is your application that is connected to a shell environment. So if I run a terminal on my local desktop, I will connect that terminal to a shell on some remote system, or I can actually run the terminal on the same and system that is running my shell in the background. So the terminal is a separate application, and it uses some protocol to connect to a shell environment. So the terminal itself is separate from the shell. So oftentimes it just get confusing, but they're really two separate applications, and they talk to each other using I/O from within the context of a terminal and a shell. And some examples of a terminal would be things like SSH. So if you type in SSH into a command prompt or a shell or a terminal on, let's say, like a Mac or on Linux or even Windows, you're going to be actually launching another terminal and then using the SSH protocol to connect to another shell environment on a remote host over the SSH protocol. Telnet used to be popular, but it's fallen out of favor because it's not encrypted. Putty is another SSH client for Windows. It's another SSH terminal. And then even the Windows terminal, this is a new application that's available from the Windows Store. The one I'm going to be using it today. It's a terminal application that allows me to interact either with Windows or with another shell environment. And Windows terminal can use PowerShell. It can use the traditional command prompt, or it can use Windows Subsystem for Linux or any other shell environment that I might be using on the remote end of that. So these are a distinction from the shell environment, but you usually launch your terminal, then you connect your terminal to some kind of shell environment, then you start operating on that shell environment. So what is a shell script then? A shell script is a program that executes within the context of a shell. So a corn shell or a bash shell that we talked about, that application that's actually running on the host. A shell script can run on that host. Now, a shell script can be run interactively, or it can be run in the background as a process. And this allows you to use shell scripts for automation where you can't see the output, but you can launch those as automation jobs, or you can run them interactively and where you're actually interacting with them through the keyboard. So the shell script is really just a set of commands that are executed in the context of a shell. And the shell itself has the ability to interpret that script based on the programming that's involved in that script. So a shell script more or less is a program for that matter. It can execute common Linux commands. So for instance, you can say ls inside, you can have the ls command or the make dir command or the chmod command or the chown command in a shell script. And so you can change things about the operating system or execute any of those common commands that are available within the context of Linux from within the context of a shell script. And with that, the output of those commands, you can actually use it for control logic, or you can use it for the inputs for other commands through variables or piping. So I can capture the output of a command and then assign it to a variable, or I can use something called piping and pump it into another command and use it as input for that command. And we're going to look at these various options for today when we dive into some of those examples later on. And this right here on the left side of the screen right here, right side of the screen, sorry, is a shell script itself. It is just basically a very basic example where I have the shell scripted. I have it. I need the highlighter, not the marker. I have the ability to declare what I'm running, and then I have some variables here, and then some logic based on those variables, and then I'm actually calling echo, which is a command, and then executing through that script. So this is a very basic script, but this is what they kind of look like in the context of shell scripting, and they all kind of take this form. But we're going to dive in and later in the webinar and talk about these specific things, what these mean, and all what's going on with these kind of examples like this. So let's go on to the next slide and look at where is shell scripting used. I've already alluded to some of these already. One of them is Linux automation, and this is the original use case for it. Linux automation, or really Unix automation. Shell scripting became the way to do what is equivalents of bash scripting or batch scripting in the context of Linux in the earlier days of Unix, and then Linux inherited that, and it's the original use case for it. However, there have been other use cases that have emerged from the original use case for Linux automation, and some of those might include things like DevOps. So DevOps is it makes heavy use of Linux scripting, specifically around when you're doing DevOps related to Linux hosting and Linux environments. So if you're using something like Azure DevOps and you're building pipelines, a big part of those pipelines will be using shell scripts to configure environments or to install software, install packages, and a number of other things that you can do with those scripts within the context of a DevOps pipeline. Docker is a huge use case for shell scripting. So if you're used to doing Linux automation, if you want to build Docker containers, knowing how to do Linux shell scripting will give you an edge on building Docker images and actually making those work. And whenever you go to build Docker containers and Docker images, shell scripting is used for installing packages and configuring those container images to make sure that they run appropriately, permissions are set, software's installed right, and things are happening appropriately within the context of those containers. Another one is something like Azure Cloud Shell. Azure Cloud Shell is an environment on Azure that allows you to run a bash script and have a shell environment, that allows you to do Azure automation on the cloud without really actually using a VM. Under the hood, it's using a VM, but it doesn't expose the VM, but it does expose the shell. And within the context of a terminal, you get a bash shell. And with that bash shell, you can run shell scripts. And so you can automate Azure using the Azure Cloud Shell with shell scripting. Another common or less common application for shell scripting is HTTP applications. I'm going to show you an example of this later in the demo in the webinar. But HTTP applications, as they were originally written using shell scripting back in the early days of the web. A lot of applications were written using shell scripts because there really wasn't another option for doing it. And that's kind of fallen out of favor nowadays. But in some cases, it is still popular to use, still okay, I say not popular, but okay to use shell scripting in the context of these applications, specifically when they're doing some kind of automation against Linux systems. And I'm going to show you an example of that later on in a demo. And then you can even use these in Windows, because Windows has opened up to open standards now with something like Git Bash or the Windows Subsystem for Linux. You can actually do automation on Windows using shell scripts. So there's several different options for doing that. So shell scripting is not limited to Linux. Most of these have a Linux context. That would be the first 5 there I mentioned, but even so, you can still extend Linux scripting well beyond the boundaries of Linux operating system itself. So what can you use for an environment for shell scripting? There's several options. If you're the most obvious is going to be a Linux box. I would, if you're not familiar with, I would recommend, if you're not familiar with setting up a bash environment, if you set up Ubuntu or Red Hat, you're going to be using bash pretty much out of the box. You can spin up these as a virtual machine. You can do that in Azure, AWS. You can do it locally through something like VirtualBox or Hyper-V or VMware on a local box. Or you can get a Raspberry Pi and install Ubuntu, Debian, Red Hat on the Raspberry Pi. And that will give you a low-cost Linux box for doing a lot of playing around with shell scripting and automation. So another one is Get Bash. So if you install Get on a Windows box, you have the option of installing Get Bash, which is a subset really of the full environment that you have within the context of Linux, but it does support shell scripts, and you can then learn how to do shell scripting within the context of Get Bash. However, my favorite one for doing this, if you're a Windows user, is to install the Windows Subsystem for Linux version 2. And this is very easy to install. If you go to Add and Remove Programs and then select on Windows Features, you can just click a checkbox. It'll install the Windows Subsystem for Linux. Then you go out to the Windows Store and choose a distribution such as Ubuntu or Debian and install that. And then with a single command, you can launch a Linux experience within the context of Windows. I'm going to be using the Windows Subsystem for Linux, and it's very easy to set up and install. You can Google how to install it, and we actually have a video on our YouTube channel explaining how to do this as well. So these are several options for getting an environment for doing shell scripting. So with that in mind, let's dive in and start looking at what are some of the nuts and bolts that go into making a shell script possible. So The first thing that a shell script has is the first line of any shell script. It's something called the shebang, and the shebang is the first line of the script that tells it what script interpreter to use. So if I run a script, I can run that one of two ways. I can either tell it which shell to use to interpret that, in this case bash or shell, which are most installed on most operating systems that are Linux, bash being the most common one. I can say bash and then pass in the name of my script as a parameter to bash, or I can set the execution flag on the script and then just type in the name of the script. Just do a / name of the script. And if I don't have the shebang, it'll try to default to a default shell environment to interpret that script, and you might end up with errors if that default is not the one that you intended for that shell script to run against. However, if you have the shebang in there, whatever shell environment that you're running in is going to look at the shebang and tell it use the path that is specified in the first line of the file as the interpreter for the rest of the script. So the two common ones are /bin/bash or /bin/sh. You can use a shebang in things like Python and Perl as well. But bash scripting and shell scripting are two common use cases for these various shebang outputs right here. So once you have the shebang set, then you can start working with your script. Now, the first thing that you want to do is figure out how to get input into your script itself. There are multiple ways to do this, and the first one is to use environmental variables. And this is a very common use inside of things like Docker containers, where you want to use a script and you need to pass in some kind of external input into that script. Well, Docker provides a way of setting environmental variables externally, and so many scripts that run in the context of Docker containers will grab those environmental variables and then use those inside of the script. And you can simply reference those with $, then the variable name inside of your scripts. And we're going to see some examples of this in a minute. The second one is using script parameters. With a script, you can specify the name of the script, and then everything after that you can use a space, and those are passed in as parameters into the script, and they will appear in the order that they are passed in. So $1 would be the first parameter, $2 would be the second, and $3 would be the third, and so on. And you can grab those parameters for the scripts as you execute them. A third way would be to use prompts. There's a command called read, and you can just use read var name, and it will prompt the user for a keyboard input for the actual variable that you're specifying, or you can use read-p, and then you can say the var name here. So I'm going to flip over. I'm going to minimize my deck here, and then we're going to look at how you might use some of these as well. So let me drop out of this, and I'm going to launch the Windows subsystem for Linux here using the Windows terminal. So this is my terminal application. I'm going to type in WSL, and this is going to launch a terminal for my local Windows subsystem for Linux that I'm running here. So if I go cd tilde and I do nano, I'm going to use the nano editor, and I'm going to edit a file. I'm going to call it input.sh, and I'm going to do my shebang. That's pound, and then I'll do /bin/bash for my shebang, and then I'm going to do read. I'm going to do -p, and then specify hello. What is your name? And I'm going to say name, and then I'm going to go echo $name. And save that, and then call it bash input.sh. And I'm going to type in blaze, and then it's going to say blaze as the output because I echoed that back. That's using that read command. However, if I want to import a variable, I'm going to do export name, and I'm going to say name equals blaze, and that's going to create an environmental variable here. And if I go set, I can view all of my environmental variables here. I've got a lot of variables there, so I'm not going to scroll up to them. But if I do set, do grep blaze, it should show me everything that I have logged in. There's that one I just set, user equals blaze, the last one, name equals blaze. So if I do if I go back to my nano input.sh and then let's comment this out. I comment using a pound sign, and I just use echo name. I'm going to be grabbing that from the environmental variable in this case. So I can do this, bash, run this again using bash, and it just echoes that variable back that I have in my environmental variables. And another way to do this is if I just specify the input parameter, I'm going to say 1, so that'd be the first parameter I pass in. I can save that out, and then if I go execute that again, it will not put out anything there, but if I pass in the parameter, it's going to echo blaze back out as well. So there are 3 different ways that you can input parameters into a bash script using environmental variables, read, and then also as parameters. However, there are another way you can do it is by reading a file, and we're going to look at an example of this, and this will vary depending on the kind of file that you're reading, but all in all, there are several ways to get input into your various scripts, and we just looked at 3 different ones very quickly there. And now when it comes to control logic, this is where you can use different operators. So these are your binary operators, and there's different set for numeric and strings, numeric operators and string operators inside of bash scripting. So when you're working with strings, you use use things that look more like the operators you'll see inside of programming, and then you use these dash operators for the context of operating within when you're working with numbers inside a bash script. So dash GT, dash GE, and so on. These are numeric operators, and then these are the string operators here. And we're going to look at some examples of these. Now, it takes a while to get used to switching between these, because usually a language like, say, C# will be able to interpolate between equals for strings and equals for numeric when you use the same operator, but bash is not that smart. It has to have a separate set of operators for each different data type that you're dealing with. So some places where you might be using if-then operators, equals operators, or something like that would be in an if-then-else. So if-then-else inside of a bash script looks like this. And it's kind of confusing. Note the shebang there. That tells me what I'm doing here. I have some variables that are being set. When I set a variable, I don't use the dollar marker. I just say, here's my variable equals, and then I pass in the value for that. So I say A equals foo, B equals bar, but I'm doing assignment there. But when I'm actually doing a test, it looks like I'm using an equal sign within the context of brackets, and that's how bash is able to know, and the fact that there's an if there, it will interpret that not as an assignment, rather it as a test operator rather than an assignment, what you see there. And also notice that in these quotes that I'm using a dollar to reference these variables. So that's important whenever you start referencing variables inside of your test or within the context of strings. If I was doing echo, I would do echo $A is not equal to $B. If I was actually going to put the values of those out, if I just say A is not equal to B, it's actually going to literally put out A is not equal to B rather than substitute the value of that. And the one thing to note is space matters here. So if you don't have the space between the brackets, it won't compile, and you'll beat your head against saying what's going on here. And that is one of those annoying things about shell scripting that you just kind of have to get used to, is having those spaces after the square brackets. And notice the closing back. It's not bracket, rather than having a double word, else if or end if or something like that, it just spells the if backwards. So phi is if backwards. We're going to see this is a convention inside of shell scripting, where if you have a code block and you end that code block, it's usually whatever started it spelled backwards. I don't know who chose to do it that way, but that's just the way it is. And for that matter, I just go along with it and I don't question it. So it's not exactly intuitive. So let's go ahead and grab this, and I'm going to show you what this actually outputs. And we can copy and paste this script into a shell script here. So let's go nano if.sh, and I'm going to paste this script in from my slide and clean it up a little bit, save it, and I'm going to go bash if.sh. And a is not equal to b because a is equal to foo and b is equal to bar. Let's edit that guy again, and let's change the value of b to foo, and run that again, and a is equal to b now. So you can see there how I'm using those if-else operators. So that's one way to do control logic in the context of a bash script. Now let's go back to our deck, and let's launch this again, and let's flip through this, go to the next slide, using case statements. Now, case statements are another way to do blocks of code that are conditional, and these are the syntax on these is a little bit strange. Most of the reason being is it's not like anything else that you're gonna have that you've experienced in other languages like C or C++ or Java or even BASIC. It uses a strange syntax here. The case statement starts with the case and it ends with case spelled backwards. The cases themselves, you use this case is foo, and then with a closed paren there, and then this is the default here, or other, and closed paren, and then this is the break. So semicolon is the break, and it's not exactly clear what those mean, but once you see it enough, you'll get used to the syntax of what these case statements are. So in this case, I'm doing thing equals foo, and it's going to go through this case statement and it's going to execute echo foo, and if otherwise, it's going to echo other. So it's the case default there, and there's the case spelled backwards. Let's go ahead and grab that code again and just use that last one there inside of a shell script so we can see what that does. So let's nano case.sh, paste that in, save it out, and do bash case.sh, and it said foo because my variable was set to foo. So let's edit that guy, and let's change this from foo to bar, and it's going to say other now because it didn't meet the case condition for my given action there. So that's the story we have there. So let's go on to our next option here, which is going to be while loops. Now, while loops behave much the same way that while loops do inside of other languages. The conventions are even somewhat similar. You do while, then you use square brackets, say while some condition is such, then you do, and then you end it with done. So this particular one will say while the variable I is numerically less than or equal to 4, it will echo that out, and then I is then iterated. So this operation here, this is a numerical comparison using that -le like we saw back in those comparison. And then the dollar operator here, what this does is it captures the output of the operation within the square brackets and then assigns it to the variable I. So I'm actually using the dollar to capture that and then assign the value. So that's how I'd increment I inside a bash script. Is using dollar and then using the brackets there to add 1 to it, and then I get the new value for that, and then I will loop over that until it is equal to 4. So to show you what this one looks like, I can drop out of this. Let's go ahead and grab the code here off my slide and do nano while.sh. I can paste that in and save it, and then exit, and then do bash while.sh, and the count is 0, 1, 2, 3, 4. And if I were to edit that guy again and I do instead of LE, I do LT, that's less than 4, it would only do it from 1 to 3 and not 1 to 4. So 0, 1, 2, 3 for LT. So I can use LT or LE. Now, similar to while loops, I can And a for loop is not like a for loop in the context of a for next loop. It's actually more like a for in loop. There is no real for next loop in a context of a bash script. You use while loops and iterate those like we just saw. But we do have a for loop here that will loop over something, a list, and basically it's going to be for everything in a given list. Now, a list inside of the context of bash would be something like an array or the output of a command. And in this case, it's I'm grabbing the output of the ls command and then echoing that back, whatever's in the list here. So it gives you the identical output of ls, but the main thing is the actual that I'm grabbing the output here and then I'm grabbing echoing it back. Now $ with the parentheses will grab the output of a command like ls, like if I want to use cat or one of the many other commands inside of inside of Linux that put something back to the screen, and I want to assign that to a variable or use it for input to a for loop. I can do that with a $ open paren, and then I can then close the paren with a command in the middle. So let's grab the text out of this and then paste this into my script here. Let's go nano for.sh, and I'm going to paste that in, and then I can call bash for.sh, and it's just echoing the same thing that I did if I typed in ls here. It's giving me the output of the ls command, and then it's just echoing this back as a single line versus just putting them out in this output right here that we see when I just type the command in directly. So you see how that you grab the output of a given command and then just use that in the context of a for loop or assign it to a variable or anything along those lines. So let's go on to our next example here. And the next thing you can do within the context of a shell script is just like you can on the command line prompt itself is something called piping. Now, piping is the ability to take the output of one command and then use it as input for the next command. Now, what this is going to do right here is it finds the file $1 in the list. So basically what I'm doing here is I'm running the ls command, and then I want to grab anything that matches the pattern that I put into the $1 variable parameter. So that's the first parameter I pass into the script. So again, very simple script here. And the pipe here just tells me to send the output from ls into grep. And that's very common use inside of a shell script or even inside the Linux CLI. So let's grab the code for this one, and I actually think let's call this one piping. So I'm going to call it ls. I'm going to do nano pipe.sh and Control X, and then I'm going to call it bash pipe.sh, and I'm going to pass in case, and that should just tell me case.sh, so it found something that had the match of case. So if I pass in sh, it'll actually give me a list of all the oops, wrong command. It'll just give me a list of everything that has sh in the file name. If I did something like, say, it'll give me everything that has I in the name of the file. So again, very simple example, but it shows you how I'm piping the output from the ls command into grep, and then I'm using the variable that I pass in as a parameter in the filter that I'm using in grep. So in that example, we're seeing kind of two things going on. Now, with that in mind, let's talk about file I/O for a second. Now, when I'm working with files, there's a lot of things I can do with files, and there's a lot more file operators than I have here. But these are some of the common ones that you can do. You can script things with files. You can read files a line at a time. Files can be overriding or appended. The tests, you can do tests on files, and you can also, and the tests on files can be used for control logic. So you can use -d, just like if you were doing a test against a variable. You can say -d file name, and it says name is a directory or its name is a file. Or if it doesn't exist, you can use you can test the existence of a directory using -d. If it doesn't find it, that means it doesn't exist. It might exist as a file though, so it's good to test for both files and directories. So -F, -R, W, and X test for particular permissions, and -S test for non-zero length inside of a file. So these are some of the common file operators you can use within the context of a given shell script for tests. So a script that actually uses something like this might look like this. So file operators would be an else if, like I have here. This is an else if right here. Elif is else if in bash. And basically I'm taking the parameter. It says, is it a file? Is it a directory? Else it does not exist. So if it doesn't exist as a file or directory, it doesn't exist. So that's basically what I'm testing for inside of this shell script here. So let's grab the output of this and test it. Let's call it nano file.sh and paste this in, save it, and then I'm gonna call bash file.sh, and then I'm gonna pass in a parameter. I'm gonna say pipe .sh, and it's gonna tell me pipe.sh is a file. If I create a directory, so go make dir test dir, and then I pass that in dir, and it's going to tell me test dir is a directory, and if I pass in some nonsense, it says that does not exist. So you can see how I'm testing all the conditions of that given if else block that I have there inside of that sample code. So again, very simple example, but you can see how you can use those different tests to look for files, directories, or other things about files in the context of a bash script. When you're reading files, this is a little bit esoteric for reading files, but it's a very confusing if you're not familiar with it. But what you're doing here is what this does is this will read a line out of a line at a time out of a file, but the input for the file comes after the done, and it's actually using this caret here, this less than, to tell it what the file is. So this is actually telling me whatever is in the first parameter is the file that I want to use as input for this while loop, and then it's going to read a line out of that, and then echo that line back. So reading files is done using this while construct. You can also do this with for loops as well, but I'm using a while while. That's just because that's what I've gotten used to using over the years I've been doing this. So let's take this example here and then run it, and grab this code, and then I'm gonna go nano read.sh, paste the code in, save it, and then I'm gonna do let's do bash read.sh while.sh, and that should put the output for while.sh out to the screen, which you see there. Now I can do that for any file. I can do it even on the file that I'm actually executing, read.sh. I can read the read.sh file, and that's what you'll see is the output there. So again, very easy to do. This is very useful for whenever you're reading config files into your bash scripts, and you want to be able to use your have a bash script that's actually configured by another file. This would be one way to do that if you're using a bash script. Writing files is another thing that you can do with bash scripts, and this is kind of reverses what we just saw. You can output the command, use the output of a command, and then you can use the greater than command to denote a new file, or you can use something that looks like on our next example here, this greater than to append a file. So on the previous slide, a single one would create a new file or override an existing file, and then this one will append a file. So it says append to $2. So this script right here basically takes the input of $1 and then will append that to the end of $2. So $2 would be a parameter and $1 would be a parameter. So let's grab the output of this command here, and of this I'm gonna call this nano append.sh, and I'm gonna read in a file and output a file. So let's go bash, and I'm gonna do append.sh, and I'm gonna read and read. First I need to create a file, so I'm gonna do touch my file.txt. That'll create a file, and then then I'm gonna call this bash append.sh, and then I'm going to say read.sh, and then I'm going to append my file that I just created with touch.txt. And then I can do cat myfile.txt, and there's the output of that commit. I basically took the read file and then echoed the output and appended it to myfile.txt. So if I run that again, we should see the output twice. So we see that output has been appended twice into that myfile.txt. So that's one example using writing files as well. So we've kind of gone over the basics of shell scripting, and I want to look at a few examples over the next few minutes. And these are some real-world examples that I've used, I've published to GitHub, and these examples are widely used. In fact, one example I'm going to show you, I've put it into I put it on Docker Hub as a Dockerized version of it, and it's been pulled over 500,000 times. And my most popular GitHub repos, 2 of them actually, are consequentially just bash scripts. So I don't know why they became popular over other ones, but the point is that they're useful. People have found the scripts useful, so they've liked them on GitHub. So the first one I want to show you is this one right here, and this one right here is this is a no IP client. So if you're not familiar with what a no IP client is, it's basically if you have a dynamic IP address, such as a residential internet connection, your IP address will change from time to time in the event that you reconnect, you lose a connection, you reconnect, so you get a new IP address, and that's your public IP address. And if you run services on your local at home on a local server, you need a way to update your DNS records that are hosted on some DNS in the cloud, and that's called a dynamic update client, or DUC, and it uses kind of a standard protocol against dynamic DNS. Well, I tried to use some of these free ones out there, and I couldn't get them to work, so I said I'm just going to write my own, and I just chose to use bash to do it in because it wasn't very hard to do. And so what this one does is you'll see a lot of the conventions that we saw a minute ago is here's a bunch of parameters I'm setting, or variables I'm setting, just string parameters, and or one numeric parameter there. And what this is doing is looking for a config file, and if it's testing to see if a file exists. If that file exists, then it defaults to this right here. No, it says, is this defined? That's what, if that exists, and if it's defined, it will set the config file to this. And then it loops over some input parameters that I can pass into this. That's what this is doing. $& is the way to grab all of the parameters as a list, and then you can loop over them using a for in loop like we saw already. And I'm using a do, and then this case right here is going against this variable right here. So the case is using, it's either u-equals, it either starts with that or it starts with -- user equals, and then that it matches that's a wildcard there. So anything that's got user equals, it's using some expression here to grab the value of that, and then it's getting the output of it and assigning it to the user variable. That's what this case switch here is doing. And then you can see I'm doing some more if stuff here, and there's more. Again, this one is if the config file is set, it actually reads in the config file. This is an example of where I'm using the config, reading in a file here, looping over it, and then it's doing a case switch on each of the lines, again looking for user equals as the start of that string, and then using a wildcard, and then it's setting a variable based on some logic here and an expression to get the value out of that. And then it's doing some logic to basically make sure the parameters are set. It's setting some more variables here based on the parameters that were passed in. And then down here, it's checking some other parameters to set some variables that actually end up getting passed into wget. And then wget then will execute again and again in that parenthesis operator that we saw, and it's assigning the results of that out to a variable, and that's a numeric value. And basically it's saying, is it 1, is it set, and then 2, is it not equal to 0 as a result of the last command executed. So dollar question mark here is the output of the last command that was run, so that'd be wget that was actually run. And if it's not equal to 0, that's the actual exit code for that. It says, what is the exit code for that? And then it does another case switch on there, and it's just doing the results of that error. And then it says, is my log file set? It will then, pass in the date. It grabs the date from the date command in Linux, and then it says date, and then that puts the result out there, the error code, to a log file, and then there's that append command, that append directive. So everything that we've covered today thus far is pretty much used in this script here, whether I'm using looping, while looping, for looping, I'm doing outputs to files, reading files in, reading stuff in from the parameters. All that is doing in the context of this shell script here. It's a fairly straightforward example. I encourage you to go check it out. If you just kind of want some sample code to go from, this will give you a lot of sample code that you can pull from for writing shell scripts. Particularly this one, I don't have a Shebang on, and I think I should have a Shebang on it, but I didn't put one on there. That's I guess I got lazy when I started writing this, but a Shebang would be useful. I think this is actually a purely shell script, so it would work either in Bash or most other shell environments as well. But I'm going to show you another one where I'm actually writing something using HTTP, and what this does is this is a simple OpenVPN server, and what the shell scripts here are doing is actually, one of them is installing it. I'm not going to go through that one, but one of these is actually the index for a given HTTP endpoint that is served up by an actual shell script. I configured a web server to pass the context of that back to a shell script so it could parse it. And then that shell script gets parsed by the parser, and then that parser then will return the output of the shell script, which would then should be HTML, and that was what gets rendered in a browser. So here you can see I'm using Echo to actually output various things about I'm actually echoing HTML back to whatever the interpreter of this is, and then that's getting passed back to the browser to be interpreted. And so you can see some embedded HTML in here. And what this is doing, actually this is a function. I didn't show you how to do functions, but you can do functions inside of shell scripts. And down here I'm doing a case operation against the option. This is actually set up here inside of the inside of a command where I'm actually parsing out the query string. The query string gets passed in as all one big chunk, and then what this eval does here is that it parses that query string based on the ampersand, which is ands everything together as a part of the query string, and then executes that query string to assign it to a variable. So if one of those, it's one command, it's one command to parse out the entire query string into variables that I can then use inside of my shell script. And one of those variables that gets output from this is option. And two options that I have here are add and revoke, and this will actually create a new client for an OpenVPN server by calling the new client here. That's a command that is part of the OpenVPN suite that will create a new client, and then it will actually write out the certificate to a file, and then I can say client for client, whatever it is named, was added, and then I can revoke that, and also I can download the script as well. So to show you what this kind of looks like here, this is the output of that file. So if I hit download, what this downloads is a OpenVPN configuration file, and that shell script is actually being passed out to another shell script that's in the same repo. It's called download.sh, and that downloads an actual shell script. And this one you can see I'm just reading in a file and echoing the content back to the browser with Echo, using that. It's almost a verbatim what we saw a minute ago in the file that we was echoing, that was doing the append operations. But this, I'm not appending it back to a file, I'm just reporting it back to the browser. And this is setting some of the headers, the HTTP headers. It's just plain text, and this content disposition is just setting the file name for that given the client name.openvpn, and you can see that I downloaded that right there in the context of my browser. So here is some example. Here's an example of two real-world examples of some shell scripts that I put out on GitHub as just projects that I wrote just to satisfy some need that I have, and I've got a lot of traction on both of these projects, not because I just not because they're particularly novel. It's just they use shell scripts to do something very simple. But in any case, like I said, this no IP script here has been widely used, and I Dockerized this, and it's been downloaded over 500,000 times on Docker Hub, because this is a very low entry level way of getting a dynamic update client inside of a Docker container without having to install 1,000,001 dependencies or compile any code. I just basically install one dependency and have bash running, and then I can use this inside the context of a Docker container. So again, it's very easy to do with that. So with that, I want to close out the webinar with any questions you might have. If you can pose those over into the box over here, and I'll go through those. You can also follow me online at the One Mule on Twitter, and if you have any questions, feel free to email me. We can also help you with Linux-based projects at Winelect as well, if you need consulting on Linux or if you need help with shell scripts and so on. And I'm going to basically take all the sample code that I put out there, and I'm going to zip it up, and we'll make that available for you, as well as links to the examples I gave you inside of here. Okay, if there's no more questions, then I'll call this a wrap, and we'll be posting this online. So if you missed the content, we'll post it online so you can consume it later, and we'll have links to the code as well as the code samples and the repositories I showed you near the end where I was executing shell scripts. So if that's it, thanks for coming to this webinar, and I look forward to seeing you on future Wintellect webinars.